Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics of the Internet of Things. So this session we can classify it into 6 parts. So we can discuss already 4 parts in our videos. If you missed out those things, in the description we are providing, please refer to it. Come, let's get into the session. So in the part 5 we are going to discuss what are the different IoT design methodologies, what are the steps involved in the IoT design. Okay, and why we need to know about this embedded computing logic, and what are the embedded system hardwares, and what are the applications of embedded system softwares, how to choose a microcontroller for the IoT, how IoT is designed on the chips, how IoT works, and what are the layers of IoT. So if you get into the design methodology, the first most important step is that the purpose and the requirement. Okay, so defining the purpose and the requirement is very much important for the IoT system. Next is the process model specification. It defines the use cases. And the third most important thing is the domain. Physical entities, virtual entities, devices, resources, all these things comes into the domain model specification. And the next step is that information model specification. It relates to attributes, everything. Okay. And next is the service specification. That is the mapping of process and information model to the services. Okay. Next is the IoT level specification. It defines the IoT level for the system. Next is the function view specification. It maps the IoT level to the function groups. Next is the operational view specification. That is, it defines the communication option, service hosting option, storage options, and the device options. And the next step is that device and the component integration, where we are integrating the devices. Okay, we are developing and integrating the components. And the final most important thing is the application development. We are developing the application. So these are the most important design methodology and steps that we need to follow when designing the IoTs. And if you get into the embedded computing, we have embedded system. Okay, with the help of IPv6 we are used to address the things. But if you get into the peripheral hardware, it can be sensors, actuators, and the drives. And when you, through the local connectivity, the local network can be a LAN, MAN, and MAN. Okay, and even with the help of the internet, we can connect with the other devices. Then it forms a IoT. And if you get to try to know about the embedded system hardware, okay, if you get going for an example for microcontroller, there is 8051, 16F8, ATM MEG, 168, 68 HCLL. Okay, sensors. So sensors can be temperature sensor, humidity sensor, light sensor, ultrasound, gyroscope. And if you're going for input, it can be a switch, keyboard, or a timer. When you're going for a controller, it can be an actuator, relay, switch, or a pulse width modulation. And notification, that is, it can be buzzer or through the LED. And when you're going for a memory of IO, it can be RFID or GSM. And display unit, it can be a 7-segment display or a graphic display or LCD. So embedded system software. So it uses the devices for a operating system. Is based on language platform. Okay, so we have vast application. We are having embedded system software in cars, telephone, modem, and so many things. Even for with the help of this 8-bit microcontroller, okay, the lighting control system we can establish with the help of this embedded system software. It has very vast application. Okay, and when you're going for a microcontroller based, bit depth is very much important. Memory, GPIO is very much important, and the power consumption. Okay, so when you get into the bit depth, the registers and the data path which impact the speed and the accuracy. When you're going for a memory, the amount of RAM and the flash in the microcontroller determines the code size and the complexity the components can support at a full speed. Okay, and if we're going for a GPIO, GPIO is nothing but it's a pin which helps us to connect with the sensors and the actuators. And with the help of these peripherals, we can connect a serial communication, analog to digital and digital to analog converters. Power consumption is a critical important thing for the battery operated devices. So how we can make a system on chips with the help of this IoT. So when you are taking a RS9113 chip, okay, it has CPU registers, okay, it has a baseband, it has a host interfaces, and it has a different peripheral devices. But with the help of this ZigBee, you can connect with the transmitting and receiving switches with the help of oscillator. It is nothing but the IO2 system on the switch. And as we discussed already in our part 1, there is a building block of IoT is the sensor, processor, gateway, and the application. So processor and sensor has a bidirectional communication with each other, and with the in the gateway and the processor also have a bidirectional communication, and for the application also it has a bidirectional communication. How IoT works? It is very simple. Okay, first it acquires information with respect to the basic resources, name, addresses, and everything. Okay, next it uses the technologies like RFID, wireless sensor, satellite positioning. Okay, in other words, sensor, RFID tags. Okay, these are all often referred as things. Second is that by virtue of many kind of communication technologies, it integrates object related information into the information network and realizes the intelligent indexing and the integration of the information related to masses of objects by resorting to fundamental resource services. Next, finally, utilizing the intelligent computing technologies like cloud computing, fuzzy recognition, data mining, semantic analysis. It also analyzes and processes information related to the masses of objects. And if you saw into the layer of this IoTs, okay, we have an access system, we have a internet devices, we have a transmission devices in the physical layer. Okay, when you get into the fundamental resource layer, we have a ID management system and address management system. And if you get into the application layer, okay, we have an information system. Okay, there we have an application. We can use for agriculture, we can use for logistics, we can use for construction, we can go for traffic, we can use for military, we can use for healthcare, and we can use for environment. And if we, the four major layers of the IoT architecture layer, sensor, connectivity, and network is the first layer. Next to it is the gateway and the network, and the third is the management services, and the fourth most important thing is that the application. Okay, so sensors can be RFID, barcode, and gateway can be WAN, Wi-Fi, Ethernet, anything. Management, that is device modeling, configuring, data flow management, security control. And if you get into the application, it can be environment, energy, hardware, retail, transportation, supply chain, surveillance, people tracking, retail. Okay, and when we see this in the software, so this figure shows in the sensor, connectivity, and network, what are the things. We have a Wi-Fi, Ethernet, LAN, wired, many things are there. When you get into the gateway and the network layer, we have many things. Okay, so here we have a microcontroller, a radio communication module, signal processor, embedded wires, SIM module, and the encryption. Even for the tags we have. Okay, and when you're going for a management service layer, we have OSS, BSS, data, security, BRM, and BPM. So what is this OSS? OSS nothing but the operational support services, and BSS nothing but the billing support services. Okay, based on the required service, we have a management service layers. Next is the BRM, that is business rule management, and BPM, business process management. And the final application layer is the environment, fleet management, energy, asset management, transportation, supply chain, healthcare, people tracking, retail, surveillance. Like that, we have many things in the application layer. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact details here. We are providing design, installation, testing, commissioning, consultancy, and training support for solar, on-grid, off-grid, and hybrid. And if you are a college student, you want training, you can contact us. We are providing training using the PLCs for automation industry. Okay, we are providing support for Allen Broadley, Delta, and Siemens. Okay, if you need really training in the PLC programming, you can contact us. We have provided the contact details here. Thank you so much. And as we told earlier, please subscribe and press the bell icon, and please share the maximum. And as we told earlier, we have so many parts discussed based on this topic. If you missed out any of the topic, we are providing the link in the description below, so that by referring that link, you can try to know about things that we missed out in the other parts. Thank you so much.